Hello, welcome back to the lecture. Subject Basic Civil Engineering, Module 1 Introduction to Civil Engineering and Civil Engineering Material. In the Lecture 6 of Civil Engineering Material, we will be discussing smart materials, testing of building materials, and FRP. What is smart material? Smart material is designed a material which can where one or more properties can be changed in a controlled fashion by external stimulation such as stress, moisture, electric or magnetic field, light, temperature, pH or chemical compounds. So these smart materials are also known as intelligent or responsive material. Here are some of the types of smart materials. Piezoelectric material, shape memory alloys, photovoltaic materials, electroactive polymers, magnetostrictive materials, magnetic shape memory alloys, smart inorganic polymer, halochronic material, magnetoclaric material, self-healing material, dielectric elastomers. So these are some of the type of smart materials. Here are some of the current applications of uses of piezoelectrics, actuation, medical sensors, energy harvesting, tactile sensors, resonators, flexible electronics. So these smart materials are widely used in these fields. Here are the application of shape memory alloys. You can see aeronautics, it is used, orthodontic arch wire, self expanding bones, staple, it is used. You can see in wild used in medical field. Robotic applications, dampers it is used, eye contact frame it is used, artwork also it is used, thin film also it is used. Uses of smart material. Smart materials are basis of many applications. Here you can see in electronics item sensors it is widely used as a sensors. In medical field it is widely used for artificial muscles. In the military it is used for various weapons making. In automobiles it is sector is used for making various sensors automatically functioning. It is also used in various medical chemical combination to form a compound. Now we'll be talking about building materials tests. In cement test we have already come across fineness test, consistency test, initial and final setting time, soundness test, strength test. Aggregate test, sieve analysis test, abrasion test, impact test, bulks or sand test, crushing test, soundness test, shape test, specific gravity test, absorption test. These are some of aggregate test. Now I'll be talking about concrete tests. Slump test, compaction factor test, VB test, compression test, split tensile test. These are some of the concrete tests. Now I'll be talking about brick test, crushing strength test, absorption test, presence of soluble salts or effluents, hardness test, size and shape test, soundness test, and impact test. These are some of the brick test. Now I'll be talking about fiber reinforced polymer. It is a composite material made up of polymer matrix reinforced with fibers. Fibers such as glass, carbon, aramide, basalt, paperwood, asbestos, etc. Here you can see fiber may be carbon or steel, plastic, etc. Resin may be a polymer. So we are saying combined it is said as fiber reinforced polymer. Some of the fibers named as aramide, glasses, carbon, basalt. Some of the resins are polyester, vinyl ester, polyurethane, epoxy. Epoxy is widely used. Properties of fiber reinforced polymer. Impact resistance. It has good strength, stiffness, flexibility and ability to carry loads, heavy loads. These are some of the properties of FRP. Now this FRP is widely used in various fields. In all each and every field it is used. Here you can see some of the pictures showing the uses of FRP. Here you can see the wide range of roofs FRP used. So these are the chart showing in different areas: port items, energy production, civil engineering materials, automatic parts, aeronautical industries, paper industries, acoustic, portable power sources, etc. Thank you guys. Thank you for listening. Stay tuned with us.